Hello everyone. Uh, as I have announced earlier that I'll start online coaching for the post of senior assistant electronics at Airport Authority of India. And as I have discussed earlier that most of the questions was being asked from electrical engineering, and I'll first start uh, electrical engineering. In electrical engineering, we will first discuss about circuit theory. And in circuit theory, we will first discuss about passive elements that are resistor, inductor, and capacitor. And in this unit, we will also discuss about what's their units, how to calculate resistor, resistance, capacitance, and inductance. And as you can see, first element is resistor, and for resistor, its unit is ohm. Resistor unit is ohm. Resistor has a property of resistance, and its unit is ohm. And how to calculate resistance for a given wire or a cylindrical rod that has a length of L meter and cross section is a square a meter square. Then which will be R equal to rho L over A. Uh, in this equation, R equal to rho L over A, rho is resistivity or specific resistance. Resistivity is a material property that tells us about material resistivity. Every material has its specific resistivity. Rho is a material constant. Rho is a material constant. L is the length of wire, that is L meter, and A is a cross section area, meter square. Ohm. And unit of rho, that is RHO, rho. Unit of rho is ohm meter. Unit of rho is ohm meter. As you can see here, resistivity of the material is ohm meter. And there is one more important parameter like resistance. Inverse of resistance is called conductance. Resistance of inverse is called conductance. And here conductance will be equal to what? A divided by rho L. And what will be the unit of conductance? Conductance unit is ohm inverse. Ohm inverse, or sometimes it's called mho, or sometimes it's called Siemens. Unit of conductance is mho. This is a symbol of mho, and sometimes it's called Siemens. And Siemens is represented by the symbol of S. And like resistivity is a rho, and inverse of resistivity is called conductivity. Conductivity is also a property of material or material specific property, and it is fixed for a material. What the unit of conductivity? Unit of conductivity will be Siemens per meter. That is equal to inverse of unit of resistivity. Resistivity unit is ohm meter, and 1 over ohm meter is equal to Siemens per meter. This is important parameter, resistivity, and this is all about how to calculate resistance, conductance, resistivity, and conductivity. And this is power loss. Power loss in a resistor. How to calculate power loss in a resistor? This is equal to P equal to V square divided by R. How this equation comes from? Let's assume there is a resistance of R ohm. Voltage across the resistor is V volt, and current flowing through the resistor is I ohm. Then power will be voltage times current in watt. What is the unit of power loss? In watt. And resistor in series. This is a series connection of resistor. Suppose there is a two resistance R1 and R2 that are connected in series. How to analyze the resistors as in series or parallel? There is a resistor R1 and R2, and only one end is connected. Only one end is connected of both resistors, and second end is open. Suppose this end is open and this end is open, then if this type of scenario is existing, then we can say resistor in series. In this condition, what is the total resistance? Total resistance or equivalent resistance will be algebraic sum, that is equal to R1 plus R2. Total resistance equal to sum of individual resistance of both the resistor. Suppose if I have two resistors, each has a resistance value of 10 ohm, then total resistance will be equal to what? algebraic sum, that is 10 plus 10 equal to 20 ohm. Similarly, if two resistors are in parallel, suppose there are two resistors R1 and R2, how to analyze that resistors are in parallel? Uh, uh, let's see. Suppose there is a resistor R1 and its upper end is connected to upper end of resistors R2, and lower end of R1 is connected to lower end of R2. If this type of scenario exists, both ends are connected to each other, then this type of connection is called parallel connection. And in parallel connection, voltage will be same across the both resistors and current will be different. Suppose we have to find out what will the current through the R1 resistor, then I can calculate by applying Ohm's law. I1 equal to voltage across the resistance R1, that is V volt, and divided by R1 resistance. Similarly, for calculating current in resistance R2, we can calculate current in R2, voltage across the resistance R2, that is V divided by resistance R2. So R2 can be calculated. Current will be different in parallel connection, but voltage will be same. And how to calculate the total resistance? Total resistance is equal to 1 by R equivalent equal to 1 by R1 plus 1 by R2. Or in simpler word, if I have resistance and resistor R1 and R2 are all equal to will be equal to value of one resistance divided by number of resistance. Suppose I have two resistance R1 and R2, each have a value of 10 ohm. Then in parallel equivalent of both resistors will be what? Value of one resistor divided by number of resistors in parallel. There are two resistors of 10 ohm, so divided by 2 and equal to 5 ohm. So equivalent resistance of this network will be 5 ohm. So it's all about resistance calculations, units of resistance, conductance, resistivity, conductivity, series parallel connections, and power loss. This is very important. How to calculate power loss in resistors. So this is all about resistors, and their units is also very important. And for more detail, you can just drop me a mail or just you can call me. Uh, Mobile number and email ID is given in the link. Okay, and this concept is very important for diploma level exams and also for some PSU exams also. Okay, thank you.